Hello, children. Welcome back to a wonderful day of math. Today we are on a lesson called Simplifying Algebraic Expressions. All right, simplifying algebraic expressions. And so we have two vocab words today. One of them is term. And a term is either a number, a variable, or a product of numbers and variables used in an expression. So a term is either a number, a variable, or a product of a number and a variable used in an expression. So if we had a math expression that looked like 7x plus 9y plus 15. All right, so if this was our expression, this would have three unique terms to it. There would be the term 7x, there would be the term 9y, and there would be the term 15, and it would have three unique terms to it. Okay, so knowing what terms are really helpful so that we can know how to simplify our expression. All right, so another word that we have is called coefficient. Yep. Coefficient. All right, and a coefficient, that is supposed to be one of those. It doesn't end with an I. A coefficient is a number multiplied by a variable. It's a number that is multiplied by a variable. So if we were to look at this one again and look at 7x, our variable in 7x would be x, right? That's a variable. And so our coefficient is the number that's being multiplied by the variable. So in this case, it's 7x. So our coefficient is 7, and our variable is x, and our whole term is 7x. Okay, and so what that means is, that if I were to have any variable, every variable has a coefficient. And so one thing that might be unique is if I were to say, all right, well, my variable is just x. Do I have a coefficient with x? I do have a coefficient with x because remember our properties of numbers. One of them was the identity, and so it says you can multiply 1 times anything and it doesn't change it. So when we have a coefficient all by itself, or a variable all by itself, it really has a coefficient of 1. All right, so any variable all by itself has a coefficient of 1. We should probably write that down. Any variable all by itself has a coefficient of 1. Any variable all by itself has a coefficient of 1. All right, so just like we have terms, we have these things called like terms. And so like terms are terms with the same variables raised to the same power. Actually, we'll write that one down too. That one's important to know. Like terms. Terms with the same variable raised to the same power. So terms with the same variable raised to the same power. Okay, so some examples of what this might look like. We'll say that 7x and 3x, those are like terms because they have the same variable raised to the same power. Both of these variables are both x and they're both raised to the same power. And then an example of unlike terms might be 5y and 2y squared. Okay, so these two are unlike terms. And because 5y is just the variable y, but 2y squared is the variable y squared. Those are not the same variable because the powers are different. Okay, since the powers are different, they're unlike terms. Another example might be w and w divided by 7. Those work because they both have the same variable w inside of the e, or connected to each term. Each term has a w. For this one, we might have 6a and 6b. These are unlike terms because the variables are different. If the variables are different, they're unlike terms. And then finally, we might have things like 5 and 1.8. These are like terms as well because they both have no variable. Even terms with no variables, as long as all the terms have no variables, they're like terms. And then another example of not would be 3.2 and n. These are not like terms because this first term doesn't have a variable, and the second term is just the variable n. Since n doesn't occur in both variables, it can't be like terms. All right, so if I were to make a list here of some terms, let's say I have 5a t over 2, 3y squared, 7t, x squared, 4z, k, 4.5y squared, 2t, and 1/3 a. So let's say I have this whole list of terms here. And I'm going to say, all right, well, let's figure out what the like terms are. What I want to do is I'm going to start with my first term, and I'm going to circle it. And then I'm going to look through and see, all right, do I have any other terms that have the variable a with no powers? So I'm going to go to my list. All right, looking for a. That is a t, y squared, t, x squared, z, k, y squared, t, a. This has an a. Those two are like terms. So I can write those over here in that connection. And 1/3 a. All right, now I'm going to go to my next one. This is a variable of t. So this is t over 2, so I want to look for any other things that have a t in them. Y squared, t. This one counts. X squared, z, k, y squared, t. That one counts as well. So my t terms are t over 2, 7t, and 2t. And all of those are like terms. All right, and then let's keep going. Y squared. Do I have any more y squares? I got an x squared, zk, y squared. Look at that. So this is 3y squared and 4.5 y squared. And let's look. All right, well, I've got an x squared. Any other x squareds? Nope. A z, any other z's? Nope. And a k, any other k's? No, no other k's. So these three don't have any pairs to them. They're all just solo dolo. All right. One last thing we want to get into today is about combining like terms and actually simplifying the like terms. So when I identify like terms, if I were to say I have 4x and 5x, okay, these are like terms, and I can combine them. So if I had an equation that said 4x plus 5x, really what that means is over here, my first value, I have 4 x's. I have 1, 2, 3, 4 x's, right? That's what this means right here. It means I have 4 of the value x. And to that, I'm going to add 5 x's. 1, 2, 3, 4, 5. So really, I'm just adding up all of these x's. These are all just adding up all together. Because remember, multiplication is just repeated addition. When I have an addition problem, I can just, and it's all the same value multiple times, I can multiply them. So same thing, I can break a multiplication problem down into lots of addition problems. Okay? So really what that means is, so here's another thing to write down. If two terms are like terms, simplify by adding or subtracting the coefficients. Okay, so if I have two terms in my expression and they're like terms, I can combine them by either adding or subtracting my coefficients. So in this case, my coefficient for my first value is 4. My coefficient for my second value is 9. And since it says plus, I'm going to add them up. And 4 plus 5 is 9. And I keep my term the same. So my solution to this would be 9x. Okay, so that would be that example, 9x. All right, so what if I had, I'll leave that there so we can remember it. What if I had 7y plus 2y? Well, again, I would look and I would say, all right, well, I have 7. I have like terms. They're both y, right? So I can combine them. I know I can combine them because I have like terms. And now since I know I can combine them, I'm going to look at my coefficients. This says 7 plus 2, which is 9. Leave my variable the same. My answer is 9y. All right, what if I had, this one's going to be a little bigger, so follow along with me. 5x cubed plus 3y plus 7x cubed minus 2y minus 4x squared. All right, so here is a bigger problem, and I want to simplify it in whatever ways I can. So I'm going to look like I did before, where I look through and find my like terms. I'm going to look to see, all right, do I have any like terms? Well, I have a x cubed and an x cubed. Those are like terms. And I have a 3y and a minus 2y. Those are like terms. And then I have this minus 4x squared all by itself. Okay, so I'm going to combine my like terms. The way I know how to combine them is I look at the operation before the second number. Okay, so if I'm looking at my x cubes here, I have a 5x cubed and a 7x cubed. And the operation before my second number here is addition. So I'm going to add them up. And 5 plus 7 is 12. And I leave my x cubed. So that's one thing I know. Now I know this. My new equation will have a 12x cubed in it. All right, now I'm going to look at my y's. I have 3y and 2y. The operation before my second value is subtraction. So this is 3y's minus 2y's. 3 minus 2 is 1. This is 1y. And again, remember, if I ever have a coefficient of 1, I can just write it as y. So now I know I'm going to have a y down here. And since this is a positive y, we'll get more into positives and negatives later, but since that's a positive y, we're going to keep it as plus. And then left over, I have this minus 4x squared here. So I'm just going to leave that as minus 4x squared. If I can't combine it with anything, I leave it with the operation that's in front of it. So I always care about the operation in front of my term. That will help me know how to put it into my final equation. So this right here would be my final equation. All right, let's try one more. One more that we like here. All right, let's say we have 2 times a plus 2a squared plus b. Let's say this is my equation here. Okay, and I want to simplify. So first thing I'm going to do is I'm going to use my distributive property. Remember that? Distributive property, I'm going to distribute this 2 to both things. And to distribute the 2 means I multiply this 2 by the coefficients of each term. Okay, so what's my coefficient of this term a? Well, it's 1. Remember, if it doesn't have a coefficient, the coefficient's 1. So I say, all right, 2 times 1 is 2, and then I leave my a, plus 2 times 2 is 4, and I leave my a squared. My multiplying out here does not affect my variables. It just affects my coefficients. And then I have this plus b out here, so I'm going to leave that all by itself. All right, now I want to look and say, do I have any like terms? Well, I have an a, I have an a squared, and I have a b. I have no like terms here, so this is just my answer. My answer is 2a plus 4a squared plus b. If I can't simplify it, then my answer is just what it was originally. All right. This is a lot. We'll talk about it some more in class, but please let me know if you have any questions. I hope this made a little bit of sense to you. We're going to be combining like terms a lot this year, so just really make sure that if you don't get this, you go back and watch it again. And again, please ask me questions. Please let me know what you need help with. I will see you all tomorrow.